Okay, let's have the second part of exponential equations, and let's have a quick recall. When a to the power of x is equal to a to the power of y, when the exponential equations have the same basis, implies that x is equal to y. Okay, for where a is not equal to 1 or 0, so I have revealed here that a is not equal to 1 and 0, and I want you to understand and I want you to discover why we are restricting the value of a not equal to 0 and not equal to 1. Let's have this example as a recall of what we have learned in the first video. Okay, so for this one, 1 over 5 to the power of 2x minus 4 equal to 125, we can say that they are not on the same with the same basis. So what we're going to do here is to transform first your expression to the same base, and it will be good if you can transform in such a way that your base is a whole number. In this case, this is in fraction form, so you can use the power or the definition of a negative exponent to transform your expression on the left hand side. Well, 125, we know that 125 is just equal to 25 times 5, and 25 times 5 is 5 times 5, or basically this is just equal to 5 cubed. Okay, so we transform 125 into in base 5, which is equal to 5 cubed. As you can see, we can simplify this one further. That will be negative 2x plus 4 equal to 5 cubed. Okay, since we have transformed the bases of both sides equal to 5, then this implies that we can equate their exponents. So negative 2x plus 4 is equal to 3, or negative 2x is equal to 3 minus 4 using additive property of equality, and then negative 2x is equal to negative 1, and divide both sides by negative 2, therefore x is equal to 1/2. So the value of x is equal to 1/2. So the solution set is equal to 1/2. So only the value of x, which is equal to 1/2, will satisfy these equations. Okay, let's have 4 to the power of x minus 2, and this is equal to 8. So in this case, our base on the left hand side is 4 and the base on the right hand side is 8. And to think of numbers that we can transform this into the same bases, we cannot transform 8 in base 4, and you cannot transform 4 in base 8. So what you're going to do now is to actually change or rename both of these bases. So how can we rename that? We can actually rename 4 as 2 squared, because 2 squared is equal to 4, and we can rename 8 as 2 cubed, because 8 is equal to 2 times 2 times 2. So in this case, we can simplify further. We have 2x minus 4 equal to 2 cubed. Since we have already arrived at the same bases 2 and 2, then this implies that we can equate the exponent. 2x minus 4 equal to 3. And solving for the value of x, we have 2x is equal to 3 plus 4. Therefore, 2x is equal to 7. And divide both sides by 2. This gives you x equal to 7/2. So the value of x is 7/2. So let's try to check if this will give us correct answer. 7/2 minus 2 is technically equal to 3/2, and 3/2, 4 to the 3/2 means 4 to the 3/2 means square root of 4 cube, and 4 cube is 64, so square root of 64 is equal to 8. So we got the value of x correctly. Okay, let's have another example. Let's have 3 to the 2x minus 4 times 3 to the x plus 3 is equal to 0. So this is kind of weird because we have an equation equal to 0, and we're used to have two expressions on both sides. Now, the first thing that you're going to observe is also that 4 here is different from the other bases. Okay, so what should we do when we encounter this kind of equation? Now, we can also use the idea of power of a power law here, which means that I can transform 3 to the 2x as 3x to the power of 2. Okay, or vice versa. Now we can have 4 times 3 to the x plus 3 equal to 0. But this will not make any difference with the original. Okay, because you still have 3 here, you still have 4 and 3 here. But the beauty of this one is that you can actually see a common term or a common expression. And the common expression is 3 to the x. And this is where we use our skills in substitution. We let a equal to 3 to the x. What happens when we rename the variable or the expression 3 to the x into another variable? Then this one, 3 to the x, will become a squared minus 4, 3 to the x is equal to a, plus 3 equal to 0. What we are doing here is actually transforming the original equation into another equation. Okay, but this another equation is just similar to the first one. We're just renaming some of the variables. Why do we rename this? Because as you can see, we are actually dealing with quadratic equation here. Once you see a quadratic equation, our next step is actually try to factor if there are factors. And I can see that the factors are a minus 3 and a minus 1 equal to 0. And using zero product property, a is equal to 3 and a minus 1 is equal to 0, so a is equal to 1. But we're not actually looking for the value of a. We're looking for the value of x. So how do we solve for the value of x? This is why we always go back to the given representation. Now, since we're given with a equal to 3x, then we can replace each of these values with 3x. So which means that the first value is a equal to 3, then therefore 3 to the x, because a is equal to 3 to the x, equal to 3. Now, since we have the same base now, we know that if there is no exponent, it is considered to be 1. So therefore, this implies that we can equate the exponent x equal to 1. So the first value of x is equal to 1. But we're not going to stop there because we have another value of a which is equal to 1. So that means when a is equal to 1, then therefore 3x is equal to 1. But they're not of the same base. So how can we transform or how can we solve for the value of x when you don't have the same bases and we can't do anything about that? Now remember also the definition of zero exponents. 1 is very flexible. That means it can transform to different numbers. We can transform 1 into 3 to the 0 because basing on the definition of a zero exponent, everything raised to the power of 0 is equal to 1. So we can definitely rewrite 1 equal to the base that we desire, and we desire the base 3. So this implies that x is equal to 0. Okay? So we have two values of x, and we're not sure if all of these values can actually be a solution of your equation. That's why we have to test each value. So when x is equal to 1, this is 3 squared equal to 9. 4 times 3 is 12, so 9 minus 12 is negative 3, plus 3, negative 3 plus 3 is equal to 0. Now let's use 0. 3 to the 0 is 1. 4 times 3 to the 0, this is 1, so 4 times 1 is equal to 4. So 1 minus 4 is equal to negative 3, plus 3 is equal to 0. It still satisfies the equation. Therefore, our solution set will be 0 and 1. Okay? So what we're actually using here is manipulating the equation and transforming it into another or new equation in order to solve for the value of x. Okay? So this is it would be better if you already mastered your laws of exponents so that you can manipulate any expressions that you have here. Okay, so I hope you learned from this one, and maybe you can try the worksheet, the posted in Schoology, for your practice exercise. Okay, see you in the next video. Bye.